Hi and Assalamualaikum. We are from Group 1. The topic that we will be presenting is linear block code. Our group members consist of me, Fahmi Sharmila binti Nasir, Muhammad Zafri bin Muhammad Zafrul, Hau Wen Min, Lam Chi Hui, and Syakir Syahiran bin Azizan. As we all know, in a transmission, error can occur through noisy channel. In order to correct the error, some redundancy bits were added to the message sequence. One of the mechanisms used to add the redundancy is the block coding. There are different types of error correcting codes used to control the occurrence of error, and linear block code was one of them. Linear block code has been applied in many fields, including digital audio and video transmission. Besides, the satellites and deep space field also use the same block coding to improve the communications of data. But why linear coding? The reasons are due to the straightforward calculation and the error patterns were easily describable. Although extra parity bit existed, linear coding does not convey any information but only detects and corrects error. However, the extra bit can reduce the bit rate of transmitter and the power. Now, let us move on to the concept of linear block code. This figure shows that k bit of message block denoted by U is encoded into an n-bit code word, which is denoted by V, where n is considered larger than k. The message block consists a total of 2 to the power of k code words. Meanwhile, the n-bit blocks can form as many as 2 to the power of n distinct sequences, also referred as n tuples. There are two properties that must be fulfilled in order for the code words to be considered as linear block code. The properties are: the all zero vectors must be present in the subset. The second one, the sum of any two code words will yield another code word member of the subspace. The relationship between the code word U, message M, and the generator matrix G is shown on the slide. The code matrix is generated by multiplying the message and generator matrix. Now we will move on to the project background. The problem statement that have been found is random bit error may occur in transmission caused by environmental interference and also physical defects. To ensure the information received at the destination is the same as data transmitted from its source, error detection and correction are required. For this scope, there are two different mechanisms that were used to introduce some redundancy for the purpose of error control coding. The first method is block coding and the second one is convolutional coding. We can identify the error pattern through syndrome digit. Also correcting the error code by adding the received code with the error pattern. It is important to recognize and differentiate the types of error correcting codes. Thus, the purpose of this study is to acknowledge the background materials for the decoding algorithm of the linear block codes. The benefit of linear block code, it can provide more protection against noise compared to the convolutional codes. In addition, linear block codes are easy to be implemented in hardware since they can be decoded in constant time. The resources that were used to obtain materials regarding linear block codes are taken from trusted websites related to digital communications and a textbook by Bernard Schuyler titled Digital Communication, Fundamentals and Applications, 2nd edition.
Okay, now for the part methodology. The first part is vector space addition and multiplication as the figure shown. Now into the part of Hamming distance, the difference between corresponding bits. The minimum Hamming distance as the figure shown, where the Hamming distance for d x equals to 0, 0, 0 and y equals to 0, 1, 1 is 2, and the Hamming distance for d x equals to 1, 0, 1, 0, 1 and y equals to 1, 1, 1, 1, 0, 0 is 3. Okay. Move to the error detection and correction capability. So, assume that the d minimum is equals to 5 and the result as the figure shown. And for the parity check matrix and the generator matrix, also the relationship between both of it as the figure shown. As an example, as the figure shown, where we can transfer the generator matrix into a parity check matrix. The last part for the methodology is the error correction decoding, where perform error detection and error correction, we could get the syndrome of R through S equals to R H to the power of T. Second, we can identify the error pattern that equals R H to the power of T. And the third one is correct the received vector through U equals to R plus E. Now to the process of linear block codes, where the data for transmission passes through a noisy channel during the transmission process. It is possible to add errors in the received signal because of this random noise. It is possible to detect and occasionally correct these errors using coding techniques. Channel coding thus allows the consequences of a noisy communication channel to be reduced. Broadly, the codes for channel error control are divided into two major methods: retransmit error correction codes known as automatic relay requests and forward error correction codes (FEC). In the first step, if an error is detected, feedback, negative acknowledgement is sent to the source node from the destination node requesting data retransmission. The errors are observed and resolved in the second case by the ECC mechanism on the receiver side. Coding approaches incorporate continuity into an information series, and these additional bits are used at the receiver node to track noisy received bits, which is the n-k verification bits are inserted for a block length of k bits. This implies that n bits are the length of the code word at the output of the encoded block. It is possible to distinguish error correction codes into two forms. The convolutionary code uses a shift register bank to take a stream of data bits and transform it to a stream of transmitted bits. A Viterbi algorithm for the encoding process is also used for this form of encryption, which is the linear block code encodes data in fixed length blocks.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syahiran dan Azizan, and my metric number is 1700069. I will touch a bit about the transmission process that Zach already presented. We can conclude that without a coding mechanism, applying a coding method over a noisy channel will increase the efficiency of BER of the same value of SNR, and or can even the same bit error rate for the lower SNR, which means that is not good. The coding gain is called the difference in the necessary signal to noise and ratio to achieve a certain BER for a given code relative to decoded devices. The trade-off occurs between the difficulty of decoder and the gain in coding. Indeed, which long code requires more complex decoder and consequently high energy usage when used to achieve the greater gain. Next, I'll talk about application in CD. Okay, to illustrate the application of linear block code, the the linear block code was implemented for the coding of compact disc CD. Firstly, the decoder offered a level of forward error correction. When the error burst surpassed the capability of the forward error correction, a level of erasure correction from the decoder was available. This erasure correction was a recover action that removed a bunch of neighboring bits that were interrupted and tried to recover the data. When the error was more serious until the error burst surpassed the capability of erasure correction, the third level of interpolation between the reliable coherent data was conducted to reconstruct the data. But when the error interrupted the data transmission severely until the interpolation was defeated, the duration of the interrupted data transmission was blank or muted. It will sound like to. In addition, application of linear block codes within coding of satellite communication was implemented by low-density parity check (LDPC) codes. These LDPC codes were the de facto standard of the high-speed satellite communication. When this LDPC code compatible with BCD code, which is type of cyclic code, the error correction capability of the satellite was excellent since the satellite can support variety of block size with different codes rate. For example, we can see that the code rates DVB S2 is supported by 1 over 5 or 1 over 3 and 2 over 5 code rates for block size of 16,200, while empowered 1 over 4 or 1 over half and 3 over 4 code rates for the block size of 64,800. This is the list code of rates available for near Earth or deep space communication that we have used today. Okay, I will go through the discussion a bit. So, noise or error were the main problem in the signal that will interfere with the reliability of the communication system. The linear code of the error control coding that control the occur of error and facilitate error detection or and error correction. Application of this linear block code is used in satellite deep space communication, or as can we know in digital audio or video transmission, and random access memory that is known as RAM of the computer device will be corrected and detected the error by the recipient of the message block when the error occurs.
Hi, I am Hau Wen Min. I will continue to discuss about linear broadcast system. Channel coding was a process of detecting and correcting bit errors in digital communication system to protect the digital information from noise and interference, followed by reducing the number of the bit error. In addition, channel coding can be performed in the transmitter and receiver. This can be seen in digital radio for the deeper understanding. In digital radios, message vector M was breaking up into K-bit block and mapping code words into N bit to encode the original message. Data can be recovered at the receiver. Channel encoder U equal to N multiplied by G at the transmitter will control the parity bit in the system, and the code word U will send to the modulator. Bipolar pulse with value of +1 and -1 to represent the binary logic level 1 and 0 will be used to transmit the code bit on the carrier through modulation process to the antenna. The information will be received and processed by the demodulator to recover the original information from the carrier at the receiver using R equal to U plus E equation. The code word will receive and send to the channel recorder using U equal to R plus E equation and form the correct vector. A systematic linear broadcast NK had a generator matrix G in the form of K times K identity matrix ratio to parity array function of the generator matrix 0 or 1. A 603 colon code will be taken as the example question for the linear broadcast system. Generation of the code word vector U was written in matrix notation as the product of message vector M and generator matrix G. V1, V2, and V3 were the three linear independent vectors that represent in 3 times 1 matrix and generate all the code vectors in generator matrix, which shown from U0 to U7. Minimal Hamming distance. Limits used to define a smaller Hamming distance between all possible pairs. In this case, 3 and 4 were the two cases for the limits. 3 was a minimum Hamming distance because the minimum Hamming weight was 3. Error was a condition when output information did not match with the input information. Error detection capability can be repeated in the terms of S equal to D means minus 1. Error correction capability can be defined as the maximum number of guaranteed correctable errors per code word. D equal to D means minus 1 divided by 2. In this case, the code was able to detect 2 bits of errors for error detection and 1 bit of error for error correction due to D means equal to 3.
Hi everyone, I am Lam Chi Hui. Today, I would like to present about the parity check matrix and the error correction decoding when the received code was 100011 for linear block codes along with the conclusion of this project. For the parity check matrix of the linear block code, the parity check matrix was expressed as H, which is equals to the combination of the matrix of transpose of parity array portion of the generator matrix with identity matrix of n minus k. From the generator matrix given by the question, the matrix of parity array portion was 101, 011, 110. The transpose of P is obtained from changing the row of P to the column of P transpose and changing the column of P to the row of P transpose. Hence, the P transpose equal to matrix 101, 011, 110, which is identical with the parity array portion. Meanwhile, for the identity matrix of n minus k, since the generator matrix provided was 6 times 3 matrix, the n minus k of the identity matrix equals to 6 minus 3 and get 3. Therefore, the identity matrix has 3 rows with diagonal 1 and get 1 0 0 for the first row, 0 1 0 for the second row, and 0 0 1 for the third row now. Finally, in order to get the parity check matrix, both the matrix of P transpose along with the identity matrix with 3 rows are combined and become a 6 times 3 matrix with output 101, 011, 110 at the left side and 100, 010, 001 at the right side respectively. For the error correction decoding that defined as S, when the received code that defined as R is 100011, the equation implement for the finding is S equals to R multiplied with the transpose of H, where the S represents the syndrome digit, while the H transpose represents the transpose of parity check matrix obtained previously. The way to get the H transpose is similar with that of P transpose. Hence, the H transpose is a 3 times 6 matrix with output 101, 011, 110, 100, 010, 001. Then, the 6 different rows are defined as vector 1 to 6 respectively to have a simpler presentation of the calculation. Then, in order to get the error correction decoding, the row of the received code is multiplied with the vectors respectively. To illustrate, for 1 multiplied with vector 1 with matrix 1, 0, 1, when 1 times 1, we get 1. 1 times 0, we get 0. 1 times 1 again, we get 1. Then, 1 multiplied vector 1 is equals to 1, 0, 1. For the matrix after this, the output are 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1 respectively. The second, third, and fourth output are ignored since 0 add with 0 equals 0. When 1, 0, 1 add with 0, 1, 0 and 0, 0, 1, the output become 1, 1, 0. The output is then compared with the H transpose to identify the error code. Hence, the wrong code was the third code since both codes are identical. Now, we have received code with 100011 and error pattern 001000. The one at the third place indicates the place of code with error. Lastly, in order to get the corrected code word U, the received code is added with the error pattern introduced by the channel. Hence, 100, 011 and 001, 000 is added together. Finally, 101, 011 is obtained and estimated as the corrected vector for the third code. For the last part of the presentation, which is the conclusion, the summary that we made after studied for the concepts, terms, and the calculation of the system of linear block codes, such as code vectors, Hamming distance, error detection and correction capability, parity check matrix, and error correction decoding, we found that the linear block code comes in handy for the error detection and correction that caused by the channel for the transmission of the signals within digital communications due to the presence of the extra parity bits. Although these extra parity bits do not convey any message, but the reduction of the bit rate and power of the transmitter were caused. Lastly, linear block codes were widely applicable in the field such as satellite and deep space communications, digital audio and video transmission, storage magnetic, and optical data storage within hard disks for the random access memory (RAM) of the computer devices. That is all from us. Thank you for watching.